Hello everyone, DB Pollen from AmbientVibes.com. What we have here today is the Juggler. The Juggler is a 17 HP, 3 VCO module. So there are 3 oscillators, oscillator 1, oscillator 2, and the third oscillator actually takes the form of a random CV generator, which modifies the other oscillators, and I'll explain to you what that means in a second. So the Juggler comes to you from AfterLater Audio, and this is based on the Benjolin circuit developed originally by Rob Hordyke, and it is controlled chaos in a module, the best way to describe it. So let's get into what it sounds like. So first of all, oscillator 1, oscillator 2, triangle core oscillators. As you can see on the Mordax data, oscillator 1 is producing a triangle wave. Now the range of this oscillator goes down into sub-audio frequencies, single digit hertz, and it goes up pretty high. Okay, so the second oscillator is largely the same. It is a triangle core oscillator. And it provides some unique features in the Juggler circuit. So the first oscillator, triangle wave. Now if we bring up the second oscillator here, you can immediately hear oscillator 1's pitch changing. The reason for that is part of the Benjolin circuit. Oscillator 2 modifies the frequency of oscillator 1. And it's best to think of it as a zigzag. So oscillator 2 coming down to this Juggler circuit, the attenuator, which I'll explain in a second, and up into oscillator 1. So right now, oscillator 2's frequency is very, very low, which is why you don't hear too many changes in oscillator 1, plus the Juggler circuit is turned down. So if we turn up oscillator 2 a bit, you can hear them getting in tune with one another. Now, each of these oscillators also have a pulse width output as well. That sounds like this. Okay, so far this is normal oscillation, normal VCO. Now let's turn oscillator 2 back down. This is the Juggler circuit. What the Juggler is a random CV generator, much like what you would see in a Turing machine. If you look on the Mordax data and look at the bottom trace here as I turn up the juggling circuit, you can see the random CV being generated. Now, the frequency of the Juggler random circuit is from oscillator 2. The higher I turn oscillator 2, the higher frequency randomization goes on. Now, the randomization feeds into oscillator 1 when I turn the attenuator on the juggling circuit. And the higher I turn up oscillator 2, the more chaos can ensue. to what amounts as some chaotic noise. Now, if that wasn't enough, oscillator 2 feeding into the juggler circuit, which modifies the frequency of oscillator 1, I can now feed the juggler circuit into oscillator 2, like this. So now we get some randomization modulation of the random modulation. Adding in the pulse wave circuit. Okay, now down below you can see the juggling circuit down here. You can see the random voltages being produced here. Right here on the third trace, the red trace. So as I mentioned, this random circuit is very similar to a Turing machine. And how it generates the random voltages. I can even hold it. I can even stop it by turning on the hold. And just like a Turing machine, I have a sequence dialed in and repeating. I can add to that sequence. Adding an oscillator 2. Yeah, the juggler module also has a number of different outputs. So we have 2 triangle waves here, we have 2 pulse waves here. This fifth one is the juggling circuit, which by itself can produce sounds, although they're a little bit more of the chaotic nature. I'll have you have a listen. Now you can use that juggling circuit to provide modulation for other modules, which I'll show you in a second. This fifth output here is the pulse width modulation output. I'll let you have a listen to that. This last output here is a combination of everything coming into through the filter and going out, and this is what it sounds like. Not much because the filter's not turned up, so I turn up the cutoff on the filter. Add some resonance. And of course the cutoff of the filter is modulatable through CV input here and an attenuator. And the fifth output we have is the XOR output, sounding like this. So adding in some of the oscillators. spirit. The filter itself has a juggle circuit, so you can add some randomization to the cutoff. So that is the basics of the... So for this next batch, what I've done is taken some of the outputs from the Juggler and put it into the Monsoon, which is a Mutable Instruments Clouds clone, also produced by AfterLater Audio. Fantastic module. I'd highly recommend it if anybody is getting into clouds or looking to getting into the sound produced from clouds. I'll be showing this module off in another video coming up to demonstrate its capabilities. But what I have is a few channels from the Octocontroller, well, actually every channel from the Octocontroller, receiving some of the modifiable inputs on the Monsoon. I have a circuits coming out of the Marbles clone, which is going back into the Juggler and is modifying the pitch of Oscillator 2. Now, as I mentioned before, modifying the pitch of Oscillator 2 also speeds up the juggling circuit, which is the random voltage. So let's have a listen to this. patch, what I did is took as many outputs as I could out of Juggler and patched them into various other modules here, just to demonstrate the complexity that Juggler can give as being the heart of a Krell type patch, which is kind of like what this is. So I'll go through it really quickly here. So we got the triangle wave coming out of the first oscillator, as you can see the green waveform there, and it is coming out and going directly into the board. The square wave coming out, going through a clock divider, which is slowing it down into an envelope, and that envelope is opening and closing a VCA, which is opening and closing that first channel. Now the second oscillator, the triangle wave, I have going into the data here, and you can see it as the blue triangular wave there. That output is coming out and is being fed into a branches, which is taking a coin toss and is deciding on whether or not the bass or the snare is going to be actuated here. This is the first channel, by the way. And here's the bass snare from the second triangle. Now the lower half of branches is also feeding in the same trigger signal with a different coin toss going into the 2 HP hat for the open and closed hi-hats that you can hear. Everything is being fed into ripples through this filter, through this mixer. Now the output, the combined output, which is oscillator 1, oscillator 2, going through the filters with the juggling circuits coming into and feeding into both of those, modulating everything around like crazy. That output, that combined output, is being fed into rings. And rings is having its pitch CV'd by a pressure points running down below. And the structure I have being fed a modulation signal from the third channel of the data here, which is coming from the square wave of the second oscillator, and that you can hear here. You get everything from a very progressive taiko type drum sound to a throaty flute to a horn. And this is really a crazy path. For anybody that complains that Rings has this all Me Too sound to it, I invite them to listen to this sound that you can get through Rings by patching in through the input. That is crazy. Now the output, the secondary output, the even output of the Rings, I had being fed back into the external input of the Juggler, which is going back through the circuit. So it's kind of a feedback loop. The PWM of the output of the Juggler is going up into a second Rings. That second Rings is being strummed by the pulse wave coming out of the Juggler, and that is going directly into the board. Now I do have the XOR output coming into an Optimix. That Optimix is having its trigger being sent to by an envelope or a trigger from PAMS. And that's triggering the output, as you can hear here. The bass sound. So the first oscillator is this. Second one is here. The third one is that second Rings, which provides a drum. Fourth is the percussion. And then lastly, that XOR output, providing a bass. Pretty wild patch.